now that the engine management system's got a whole bunch of information from the sensors, it can start making decisions about controlling the fuel injectors and the ignition system. Fuel injectors come in a range of different shapes and physical sizes, as well as different flow rates and spray patterns. They also have different solenoid resistance values and opening or injector dead times. The physical shape and size of the injector depends on the application. They're available in a top feed and a side feed configuration. Top feed injectors are typically more common and are available in a wide range of lengths, including 34, 48 and 60 millimeters. These measurements are taken from the bottom O-ring to the top O-ring. These are the O-rings that seal the injector into the fuel rail, and they're normally 11 or 14 millimeters in diameter. The injector opens and closes using a solenoid, which is energized by the ECU. The amount of current it takes to open that injector is a function of the injector's resistance. We can measure the resistance of an injector using a multimeter set to the ohms setting. We should see a value of somewhere around half to 15 ohms of resistance for most injectors. Because we know the resistance of the injector and we know the running battery voltage of the car, let's say about 13.5 volts, we can determine the current draw of the injector using Ohm's law. Let's use an injector with a resistance of 9 ohms for this example. Ohm's law states that voltage divided by resistance in ohms will determine the current draw in amps. So 13.5 volts divided by 9 ohms equals 1.5 amps. Each injector will draw 1.5 amps at 100% injector duty cycle. If we were controlling 6 injectors, we'd be drawing 9 amps at 100% duty cycle. If you're using an aftermarket engine management system, you'll need to input the injector current draw per injector in amps into the software. This will allow the ECU to drive the injector correctly. If you're using a stock engine management system, you'll need to ensure the system is capable of supplying enough current to open your new injector. A good way to ensure the factory ECU can drive your new injectors is by measuring the stock injectors and ensuring your new injectors have a higher resistance value. I'm sure that you would have heard of injector dead time or injector latency by now. This is the amount of time it takes for the injector to physically start injecting fuel after the ECU has turned the injector output on. Think of it this way, when the injector output opens, it takes a certain amount of time for the injector pin tool to start to move and to get to the point where fuel starts to flow through the injector. This is known as injector dead time, the amount of time it takes for the injector to start flowing fuel after it's been turned on. Injector dead time depends on battery voltage and fuel pressure and is important to map correctly, especially at light load and idle conditions, where the majority of the injection time's taken up with dead time. As an example, let's use 1.5 millisecond as our total injection time. Depending on the injector, we may have 1 millisecond of dead time, leaving only half a millisecond for the actual injection event. When we apply fueling compensations for different air or coolant temperatures, for example, we don't want to apply that compensation on the dead time values, only on the actual injection event. Likewise, injector dead time is important to compensate for when we're determining the mass of fuel going through the injector.